problem. 174 dungeon game. So for this problem, we want to go from the top left corner, and this is the top left corner, and we want to reach the bottom right corner. So the precise is at the bottom right corner, so this is the precise, and we want to calculate from the top left to the bottom right, and we can only go to the right position, or we can go to the downward position. So we can go to the right, or we can go to the downward, but we want to have an initial health. We want to choose the initial health as small as possible, maybe 1 or maybe 7 in this example. So in this example, if it is 6, if we choose this root, 6 minus 2 minus 3, it's going to be 1, 1 plus 3 plus 1, it's going to be 5, 5 minus 5, it's going to be 0, but this is not okay. But we have to have a health going to be more than 0, it means at least 1. So this means it's going to be 7. And then when we go to this position, our health is 1, and we can save the princess. So this is the basic idea. Yeah. So for us, we just need to calculate what's going to be the minimum initial health. Normally for such problem, we can use a guess. If we're gonna use a guess, normally it's gonna be the boundary search. So if we're going to use a boundary search, we just guess a value. Maybe this value is gonna be 7, and we want to use a DFS maybe, and we're gonna use this DFS to calculate what's gonna be the what's gonna be the minimum initial health. Maybe 7. We're gonna choose this route, and for the DFS, definitely we can solve the problem. Yeah, because for DFS, we're gonna start from here and here until we find the minimum path. Yeah, minimum path sum for this problem. But if we choose other paths, we cannot go because the initial value is only 7. For example, 7 minus 2 minus 5. So this is 0. So we cannot go from here, or we cannot go from here. So this means we can only choose this path. This is the only path, and the 7 is okay. Now let's just use this idea to solve the problem. So first of all, we're gonna prepare boundary search. So the minimum health value is gonna be 1, because at least we're gonna have a value of 1. Otherwise, otherwise I'm dead, and I can never save the princess. Yeah, and what's gonna be the maximum value? Maximum value is gonna be 4 times 10 to the power of 7. Yeah, so this means if this is so if this is a grid, if we can choose a path like this, so how many values actually? Yeah, the maximum m or maximum mn gonna be 200. Yeah, but we can only choose a value like that. So this means it is 200 plus 200 times 1000. Yeah, so this value is gonna be 399 times 1000. Yeah, basically this value is less than 4 times 10 to the power of 7. That is why we're gonna choose the maximum value, 4 times 10 to the power of 7. And the result, we're gonna set it as 1. And now let's just write the boundary search template. So for the m, it's gonna be L plus R minus L divided by 2. Now we are going to use a DFS to check. So if DFS with I'm gonna start from the top left corner with m. So if this is possible, I'm gonna set the result equal to m, and the r gonna be equal to m minus 1. So else, so L gonna equal to m plus 1. And finally, we want to return the result. Now we are going to write a DFS, but this is going to be a dynamic programming, normally for the this kind of a grid problem to calculate the minimum sum for one of the paths. Yeah. So we're gonna define a DFS. It's gonna be starting from RC with I'm gonna set it as a total value. Yeah. So we can write it easily to check if it goes out of the boundary. So I want to prepare some variables R and C, so the length of the dungeon and how many columns of the dungeon. So it's going to be dungeon 0. Yeah. So if R more than capital R or C more than or equal to capital C, it means it is not possible. It goes out of the boundary. Otherwise, it's going to be possible, and we're going to update the total value. So this value is going to be total from the beginning. It is m. So this m going to plus the downdrain with r and c. Yeah. Now we are going to check if we can reach the end. So this means if r equal to r minus 1 and c equal to c minus 1, so we're going to reach the end. Yeah. But we are not sure if it is going to be true or false. So if we were to return true, so this means the total must be more than 0. So otherwise, we're going to return a false. Yeah. So else, we're going to return a false. Yeah. Finally, we want to let the DFS continue to search until we find an answer. But the condition is that this total. So if the total is more than 0, we can continue the search until we find the final position, and we're going to give a return true or false. Yeah. So we're going to search to the right side or the bottom side. So let's first go to the bottom side. It's going to be r plus 1c with this total. Or we can go to the right side. It's going to be rc plus 1 and the total. Yeah. So this is going to be the DFS, and this is going to be the boundary search. So I think this is a pretty good problem. And because we are using the cast, so here the time complexity is going to be m times n. So this means it's going to be 4 times 10 to the power 4. And here is basically boundary search. It's just a small number. That is why it should work. Now let me just run it to have a check if it works. As you can see, it works. Now let me just submit it. As you can see, it works and it passed all testing cases. I think the speed is okay, although it is a little bit slow, but it is okay for 1.6 seconds for this problem. I think that's all for it. Thank you for watching. See you next time.